Have you ever pondered the outcome of a nuclear bomb detonating in space? Not within Earth's atmosphere, but deep within the unfathomable realms of our galaxy. It's an intriguing, if somewhat terrifying, thought experiment. Today, we'll venture into this hypothetical scenario and explore the science behind it. Firstly, it's vital to understand the fundamental workings of a nuclear bomb. At its core, a nuclear bomb relies on nuclear reactions, specifically fission and fusion. Fission is the splitting of a heavy, unstable nucleus into two lighter nuclei, while fusion is the process where two light nuclei combine together, releasing vast amounts of energy. In both cases, the mass of the resulting parts is less than the original, and the missing mass is converted into energy as per Einstein's famous equation, E = mc2. Now let's take this bomb and place it in the void of space. What happens? Well, on Earth, a nuclear explosion produces a shock wave, a burst of radiation, intense heat, and a devastating electromagnetic pulse. But in space, it's a different ballgame altogether. Space, as we know, is a vacuum, devoid of air or medium to propagate shock waves or carry heat. So a nuclear explosion in space wouldn't create a mushroom cloud or a shock wave as we see on Earth. The absence of an atmosphere also means there is no material to absorb the bomb's intense radiations and no air to conduct heat away from the initial blast. Instead, the explosion would release a sphere of plasma, a superheated gas made of charged particles. This plasma would expand in a bubble, radiating light and other electromagnetic waves. The bomb's radiation, rather than being absorbed by the atmosphere, would travel across space at the speed of light. The real danger, however, lies in the electromagnetic pulse, or EMP. This pulse could potentially fry electronic systems on any spacecraft unfortunate enough to be in its range. But unlike on Earth, where the EMP effect is localized, in space, the EMP could travel vast distances, affecting a much larger area. In summary, a nuclear explosion in space would not result in a shockwave or a mushroom cloud. Instead, it would produce a rapidly expanding plasma bubble and an EMP that could wreak havoc on electronic systems. The bomb's radiation, rather than being absorbed, would travel across space at the speed of light. So while the thought of a nuclear bomb detonating in space might initially sound like the stuff of science fiction, the reality, as we've seen, is a fascinating blend of physics, nuclear science, and cosmology. It's a testament to the incredible complexity of our universe and the intriguing, often unexpected ways it behaves.